early in my career, I was a fire protection engineer at a nuclear power plant. And one of the early incidents, one of the few incidents we had there, a couple, involved a crane operator who was moving the traveling crane, which goes across the turbine deck for scheduled outages, for repairs, for forced outages, scheduled outages. It's the way we do the maintenance of the steam turbines and the generators and some of the heaters. This crane, whenever it went from unit 1 to unit 2, the control room was on the turbine deck in between these two units, and there was a interlock that prevented the crane from just going right over top of the control room. He had to go back over and then come back around and then go. So the crane operators thought it was a pain in the butt, and they overrode that little lockout. One night at 2 in the morning, they're going across the turbine deck, and they've got the crane chain fall hanging down, and it's a little too low. Now let me tell you a little bit about the control room and what's about to happen here. You'll understand why it wasn't good that that chain was too low. The control room, this is a boiling water reactor, two of them. And if you had a release of radiation, the control room is set up to be pressurized with clean air so that the operators can stay inside the control room while they safely shut down the plant. That's achieved by a system called the standby gas filter. The standby gas filters have charcoal in them, and that's how they scrub out the radioactive gases that might be in the air coming from the outside to clean it before it comes into the control room. These standby gas filters, over the years of just air flowing through the ventilation system, vibration, some of the charcoal starts to vibrate out of the filters. In the bottoms of these filter trains, the ductwork that holds these filters, there's drains. Because since the charcoal is combustible, the fire protection world decided that we needed to put sprinklers in this ductwork to spray on charcoal in case it caught on fire. That was the standard method of protecting a charcoal filter train. What happened was a accidental discharge of that standby gas filter train, of that charcoal. An accidental discharge of that deluge system, the sprinklers that protect that charcoal, started to wash the charcoal even more into the drains that were already now clogged with charcoal. What ended up happening was the ductwork started to fill with water. And that water, dirty water, sprinkler rusty water with now carbon in it from the charcoal, and that now starts to pour in to the control room on the panel boards. The plant was operating at full power, 850 megawatts. It's a pretty decent sized boiling water reactor. What happened was, as the water started pouring out of the ventilation ducts onto the control boards, a safety relief valve, manual control, operated because it was shorted out. It basically got the signal that the switch was closed. So it gave the signal for the safety relief valve to open. There were 12 of these safety relief valves on the reactor. Now one of them pops open. The operators knew something was going on, so they tripped the reactor. It didn't matter. They did not have control of pressure because that valve was open and it wasn't by their doing, and they couldn't close it. At least at this point, they couldn't close it. So for a few minutes, this steam is blowing out of the boiling water reactor. It's going into the torus. It's not going out into the environment, but it definitely, it was escaping the reactor vessel. So the reactor vessel was depressurizing. And just like if you take an aerosol can and you spray it when it gets cold, that's what happened to the reactor vessel. The fuel inside in particular. So the cool down rate of the fuel was, the limit on the cool down rate of the fuel was 100 degrees per hour, 100 degrees Fahrenheit per hour. If you cooled it down faster than that, which we did, we had to shut the reactor down, which we ended up doing. What it took was knowing the fuse to pull. The problem with knowing the fuse to pull is when you go look at the drawings that have not been updated yet because a modification was still in the process of being implemented. And when you look at the steps it takes to implement a procedure in a nuclear power plant, in those days, even in those days, a search through the document record system finally showed the step that the update was in, that the design change was in. And that step was in the as-built notice phase. So the as-built notices where they actually changed the drawings and they said what fuses it would need to pull, they needed to be signed, and then they needed to be signed again, and then they needed to be signed again. In this sequence of signatures and approvals, they hadn't gotten through all of the steps. It takes a couple of days for a document in those days. It wasn't electronic. Our documents had to be hand carried. It took a few days to get 4 different approvals before, and this was, affecting the plant, and it was affecting the shutdown and the actually the safety of the plant. Well, they were able to find where it was in that 4-day step, jump into it. It was on a shift supervisor's desk who was out for the weekend. And when those guys are out, they work shifts, and he could be up in the mountains hunting deer and not have any idea that people need him to be in there to sign this document. Those kind of things are not happening anymore. But that's the kind of problems we had running the world on paper. When they found that step, they were able to go in and pull the fuse, which was able to shut that relief valve and give pressure control back to the operators. Once it was isolated, they then could increase or decrease pressure with their normal equipment. So at that point, the investigation and the finger pointing began. So in order to make sure that the fire protection system, remember that was what kind of got all this started, to make sure that it would never accidentally dump water on that charcoal again, the supervisor of fire protection engineering decided to have a spool piece cut out of the water supply to that deluge system. And then he put a hose piece with 2 swivel female connectors on it, so that if there was ever a fire in the charcoal, somebody would have to manually take this piece of hose and connect it on both ends, because what he was told when he got there and they found out that a fire system had initiated all this, and he didn't say it was the crane operator that initiated it all, but the fire systems got blamed for it. He was told, if it ever happened again, it's your job. He said, I'll make sure it never happens again. And that's what we did, was to put a spool piece in, and it never happened again.